हरि करना।
So we have seen the history of the chi-square distribution. So how the Carl Pearson has no, has brought up this chi-square distribution out of his necessity. So now we will look into the step-by-step guide to build a chi-square distribution from scratch. So why are we doing this? Because before you use a chi-square distribution, you should know how that chi-square distribution was built. So then only you can use it very well. So that's the reason I just want to make you understand how the chi-square distribution was built from the scratch. Let's do that. Let's do it with an example. So the first step in building a chi-square distribution is choose the degrees of freedom based on the number of categories in the categorical variable. For example, if your categorical variable consists of 5 categories, then your degrees of freedom would be 5 minus 1, that is equals to 4. If the categorical variable consists of 10 categories, then your degrees of freedom would be 10 minus 1, that's 9. So once you have decided upon with once you have calculated the degrees of freedom, then we will calculate the chi-square statistic for each category by subtracting the expected frequency from the observed frequency and squaring the whole result and dividing by the expected frequency. Then we'll get the chi-square that you can see on the screen, and we have to do this calculation for each category. If you have 5 category, and you will get the 5 chi-square score for each category. So 5, and if it is 10, you will get the 10. So once you have calculated the chi-square statistic for each category, then you have to sum up all these chi-square statistics. So sum the chi-square statistic for each category to get the total chi-square value, and this is our total chi-square value. So in this example we have 4, so 1 2 3 4, and then the chi-square total chi-square was 80. Once you got the calculation of chi-square, then repeat the steps 2 and 3, calculating the chi-square statistic for each category and summing up multiple times for different samples. You have to take maybe 1000 samples as or 2000 samples. For each sample you have to calculate the chi-square statistic as well as sum it up, and then you'll get a total chi-square value. So once you repeat all the steps for different samples of the categorical variable, then you can plot the histogram of the chi-square values obtained from the different samples. That's what is your chi-square distribution. So now let's take one simple example, and then let's understand this well. Okay, so what will we do here? Yep, I'll take this. I think ice, or let me decide which one would be better. Okay, so I'll write it down. Building chi-square distribution. Okay, so let me put it one. Yeah, so let's go step by step. I have explained what is that now. So we'll take one example for building a chi-square. Okay, select a categorical variable. That's our, let's decide a categorical variable. Select a categorical variable. Categorical variable that I want to analyze, or you that I want to analyze. So let's say we want to analyze, first one is select a categorical variable. First thing, let's say we want to analyze the distribution. We want to analyze the distribution of hair colors among a sample of 1000 people. Okay, that's what we want, among 1000 people. So now our variable is decided upon. So hair color is our categorical variable. Now, so hair color is our categorical variable. Now we have to create a frequency table that shows the observed frequencies. Total how many how many entities or records we have? 1000. So now let's create a frequency table. Let's create a frequency table that shows the observed frequencies of each category. So here anyway our variable is hair color. So for me, so hair color is our variable, and on other side you got the frequency. So we'll take 4 categories of this hair color. So first one is brown, of course. 450 people we have, and then blondie we have around 300. Then black, obviously Indians, it's 150, and then red, so you got around 100. So that's what is our data frequency. So this is our step 2. Now, so once you have created your frequency table for the various categories, now let's calculate the expected frequency for each category. So step 3, calculate the expected frequencies for each category. So the expected frequency of for each category can be calculated using the total. Let me write down. Expected frequency is equal to total sample size times expected proportion. So this is what. So for example, if we assume that, let's take, this is our hypothesis. I'm taking as hypothesis. My hypothesis is I'm assuming that the expected proportion of brown hair is 0.4. Then the expected frequency would be, because for the brown hair, then the expected frequency for brown hair would be, this is my hypothesis. I'm saying this is my hypothesis, 1000, that's the total, multiplied by 0.4, so it would be is equal to 400. 400 is my expected frequency for the brown hair. So same thing you have to do it for the others. So let me calculate for other categories also. So let me put it in table. So hair color and frequency, let me copy this directly from here. And paste it here. So for me, hair color, frequency. Now I need to attach one more, that is expected frequency. So expected frequency for this, again it's an hypothesis. I'm saying 400. Then for this I'll go with 300. Then for this I'm gonna go with 150. And for this one I'm gonna go with 100. Okay, so that's what is the step 3, calculating the expected frequencies for each category, all done. So now it's time to calculate the chi-square. So step 4, calculate the chi-square statistic using the formula that we have discussed. I'll show you that formula. So it is chi-square is equals to sum, it's a subtracting the expected frequency from the observed frequency and then squaring the result and dividing by the expected frequency. That's what is our chi-square. So chi-square is equal to, let's do it for one. So first category 450, that's my observed. 400, and do it square of it, and then divided by 400. So put it into the whole bracket. This is for that category. Now I have to sum it up for the all the categories. So that's what I'm going to do here. This is for first category, that's a brown, and for the blondie it is 300 minus 300 divided by expected 300. Okay, next I'm gonna do it for the black too. For black, again for black it is 150 150 150 150 and divided by 150. And same applies for red. Red it is lesser, 100, and then even my expected also 100, and then expected frequency is 100. That's it. The chi-square statistic, the total score has been calculated, and after calculating we got the value of is equals to, we got 12.5. That's my chi-square statistic. Okay, so we got 12.5. That's what a chi-square statistic, total chi-square statistic. Now step 5, repeat steps 2 to 4 multiple times to generate a sample of chi-square statistics. Let's say we generated 1000 chi-square statistics for each sample. Of course, we have the 1000 samples, and for the 1000 samples we have generated 1000 chi-square statistics using different samples of 1000 people. Okay, 1000 people. So that's what is our step 5. So once that is done, we have to plot a histogram. Step 6, plot a histogram of the chi-square statistics. So to visualize, we'll plot a histogram of the chi-square statistics to visualize the chi-square distribution. So each bar in the histogram represents the number of times that a chi-square statistic fell within a certain range of values. So that's what the histogram is gonna show here. So each bar in the histogram represents the number of times that chi-square statistic fell within a certain range of values. So that's it. Once that is done, you should be able to see the chi-square distribution. So let's, of course, to do with manually building, that is very difficult. So that's why I'm gonna use an pandas, no, NumPy and Matplotlib to do the same activity. So let's do that. First, let's import NumPy as np, and then let's import Matplotlib .pyplot as plt. So once this is done, let's generate This is the first step. Once that's done, let's generate 1000 random samples. This is very important because we want to do it for 1000 samples now. So 1000 random samples from the chi-square distribution, for the chi-square distribution with degrees of freedom is equals to 5. This is not the same example, so or else we'll take a degrees of freedom. For that we got the degrees of freedom of 3 because we got the 4 categories, and then out of the 4 categories you have around so n minus 1, so our degrees of freedom would be 3. Let's take that only. So I'm building, so degrees of freedom is equals to 3, and then samples. So now samples is equals to np dot random and chi-square df, and then size is equals to 1000. So now let me execute and check the samples, how many samples we got, and these are the samples. Total we got the 1000 samples of it. So 1000 samples with degrees of freedom of 3. Okay, that's done. Now let's move ahead. So let's plot the histogram of the generated samples now. So because we got our samples, and then the chi-square score also has been calculated for the each sample. So that's what you can see here. You can see the chi-squares here exactly. So the chi-square of the each sample you can see on the screen. You see that the samples. So the chi-square score of the each sample which has been calculated for the 4 categories, because we have mentioned the degrees of freedom 3, that means 4 categories minus 1, that's the degrees of freedom. And using the degrees of freedom and taking the 1000 samples, it is calculated the chi-square for the each sample. So now let's plot the histogram. Let's plot the histogram of the generated samples. So plt.hist, and obviously samples is on x-axis, and I'm gonna go for the bins of 20. Let's see, we'll do with the bins of 20, then we'll go for the other one. So then density is true. That's it. Now let's also add plt x label. So x label would be obviously what's my, no, this is I'll just put chi-square. On chi-square scores I have chi-square statistic of hair color. Okay, and plt dot y label. So in y label we have a frequency. This is pretty simple, frequency. And then let's put the title here. Plt dot title we can put, so chi-square distribution of hair color. And then finally let's show, and here is your chi-square distribution of hair color. We have built it from the scratch completely, and this is how your, of course this is skewed towards right, that you can see on the screen, but that's how normally it works. That's how, because normally even most of the phenomena works this way, because if you come to the India, 80% is, no, 90% is, no, 99% is will have a black hair. The remaining people will have different colors, but that also they will be colored hairs, not completely the genuine ones. Okay, that's how we calculate the that's how we build the chi-square distribution from the scratch, from step by step. So that's it. Simply calculate the p-value for the observed chi-square statistic. Then the p-value is the probability of getting a chi-square statistic as an extreme of as the observed value. So this calculation of p-value from this chi-square statistic we will be seeing in our next slide.